All right. Well, thanks a lot for inviting me to speak today. I'm Jack Kiefer with Hazen and Sawyer. The topic of my presentation is going to focus on water demand and water demand forecasting, and specifically with regard to trends and drivers and uncertainties with respect to urban water consumption. So if you kind of think of the overall trends in urban water use we're seeing, that over the last 20 years or so, we've seen per capita use or water use per person decline in many places, not everywhere, but generally I would say in many, maybe the majority of places nationwide. We've also seen some acute declines more recently in some areas that were perplexing. And these declines in consumption and some of these uncertainties can cause some real problems for water utilities in terms of net revenue, stability, unused capacity, stranded capital, disruptions of plans, things like that. Also, we can, in these circumstances, the case for improved water efficiency or programs that might make us more sustainable over the long term can become harder to sell. And so this slide here, basically the panels show some information on per capita use in the blue line and total water use in the gray line, indexed to 1985 values for a range of different water systems, urban water systems around the country. And the takeaway from this is you can see in a lot of these places this diminishing per capita use playing out, as well as quite a bit of variability. And so, forecasting consumption is a pretty difficult job, and it's pretty wrought with uncertainty, especially if you can't or haven't anticipated some of these trends. Now, uncertainties lead, invariably to inaccuracies in forecasts. And these, inaccuracies lead to a variety of risks to urban water providers. There's a study in publication right now, there's a screenshot there, where we've been looking at the role of uncertainty in long-term water demand forecasts and looking at risks, et cetera. This slide just shows some of the risks that are tied to forecast inaccuracies. From a shorter-term perspective, water providers don't want revenue surprises. It can cause insufficient cash flow, higher borrowing costs, unexpected needs to change rates, credit rating downgrades in some cases. There's the risk of oversizing systems and unused capacity that you still have to pay for, opportunity costs of those investments, including environmental damages and financial issues. Undersizing the systems, on the other hand, can lead to more chronic or more frequent water shortages and the economic damages that come with that. And to the utility, the risk would be lost water sales. So if I had to kind of condense this down, it seems that the water utility industry seems to have a greater appetite for accepting the consequences of oversizing their systems historically, but that may be changing in the future. Now, as part of this study, we did a little survey of about 80 to 90 utilities, and we asked them, what are the three main drivers of uncertainty about your future demands over the next 20 or 30 years? And we gave them a pick list of different options. And aside from the top line there, future population or the number of customers they have to serve, you can basically condense the main concerns in terms of forecast uncertainty and water demand to boil down to uncertainty about climate, the economy and economic activity, and trends in water efficiency. And so I've tried to organize the remainder of my slideshow around those basic themes and the Water Research Foundation work that I've been involved in to some degree along those themes. So the first theme is, the water use does indeed, and the patterns of our consumption do reflect the technology we use. And national plumbing fixture standards that became effective in the early 1990s have certainly had a marked influence, especially on residential water use. There's some screenshots of some of the studies. Most recently, an update of the residential end uses of water study, which was just published earlier in the year, breaks down consumption into the major end uses where we can get a better sense of what's behind some of these trends, especially in the single-family residential sector. So, compared to less than 20 years ago, indoor use per household, and we call it domestic use, has dropped by about 22%. And the two major end uses responsible for this drop is the amount of water used by toilets, which dropped by about 29%, and the average use for clothes washers, which dropped by about 42%. And what's interesting is, none of the behavioral aspects really change that much. On average, we still tend to flush the same amount and wash the same number of wash loads in a given time span. So there's pretty significant drops in consumption. But, if you think about it, if you go out, he's still using toilets as an example. If you go out to buy a new toilet at Home Depot these days and you're looking for a 1.6 gallon per flush toilet, which is the current standard, it's almost impossible to find. The market for efficient water-using devices has really been transformed, and you can really only find like 1.28 gallon per flush toilets as an example. And so the new technology is exceeding existing standards, and their substantial increases in efficiency are still likely. And this diagram below suggests from that study that indoor per capita use in the residential side could still drop by about 35% more on average, and that's under existing technology and without any changes in behaviors. So just to give you another idea of what's behind this, some work I did for the city of Phoenix, I don't know, about 10 years ago or so. We did a large sample of single-family homes, and we looked at their toilet fixtures and said, okay, are they efficient or not at the time, meaning are they 1.6 gallon per flush toilets? We broke them into these housing age cohorts, and you can see over here that the newer homes come in more efficient, and the older homes still have quite a bit of capacity to replace old, less efficient fixtures. And the key here is that as these guys retrofit in the future, they're not even going to go to the current standard. They're going to exceed the current standard and put some more pressure downward, at least on indoor consumption. Here's some additional evidence of the impacts of efficiency, some work we did for New York City, where we were able to estimate, back in the late 80s, given their housing stock, an average of about 4.65 gallons per flush across all the toilets in the city, diminishing all the way down to the near present to just a little bit over 2 gallons per flush. And so you can see then the green line kind of does match this downward trend in their in-city production demands as it goes down. And so I wanted to back up there. So if you see this great big dip right here, this is actually a large-scale toilet rebate they did back in the 90s. So that's the efficiency side of things. With regard to the economy, water, just like many other goods, at least in an urban environment, is a commodity for sale. As households, we use water at home. We purchase the water using incomes we earn at businesses. We use water while we're at work and produce things using water as input. And so you can see from a kind of a neoclassical perspective, any kind of disruption to what we might call the labor or the goods market will find its way into affecting water demand and revenue and affecting the operations of the water utility. Now, the Great Recession, really served as a really nice test bed to look at some of these economic impacts and see how the macroeconomy affects water consumption. And this is a recent report that was just published called Water Demand Forecasting in Uncertain Times, which looks at the role of the economy and water demand. We did a survey there, and we found that the majority of our respondents, we had about 123 surveyed utilities, that the vast majority had seen declines in consumption during the recession period. The modal or the pluralities of the systems we surveyed showed a decrease in demand of about 5 to 10%, but there were some utilities, about 32% saw decreases in demand that exceeded 10%. 8% of our samples saw pretty large dips in their consumption, and they tended to be in areas that were in high foreclosure areas, in places in the Southwest and the Southeast that were hurt pretty hard by the recession. So kind of leading up to that project, we were looking at water use records in places where we were working and noticing things like this drop. And you'll recall from my introduction that, sometimes water efficiency gets blamed for some of these these drops in consumption. And the question was, this is Fairfax Water, Virginia, is water efficiency the cause of a 15% drop in consumption in 1 year? Well, we doubt it. Or in Tampa Bay Water, this shows that they experienced about a 17% drop in consumption over about a 2 or 3 year period. In San Diego County, in this case, hopefully you can see it's about a 30% drop, acute drop in water use that they saw over a pretty short time span. And so this kind of gave us fuel to say, hey, Kate, let's get a study going and try to understand what's going on. And I'll give you a few examples of some of the output of those studies. Tampa Bay Water was a case study for this report. I'm actually in Tampa right now. They're the largest wholesale provider in Florida, serving about 2 million people in the Tampa Bay region. They've experienced some real rapid growth and some real rapid declines. This plot shows regional water deliveries for Tampa Bay Water from 1991 to 2013, with seasonality taken out. And you can see that they had about a 100 million gallon per day average swing over about a 7-year period. And so, 218 up to about 268 MGD. Now, if you were forecasting during this time frame, which we were, you might want to say, hey, we better get ready to plan for additional facilities. Now, on the other hand, look at the big drop, basically just took all that growth away during that recessionary period. Now, the orange places here, the orange highlighted dots, are when there was 1 day per week watering restrictions in the region, but you got to realize that over the entire time frame here, there were 2 day per week watering restrictions in place in the region. Just to give you an example of some of the indicators we looked at, in this region we found that peaks in the unemployment rate basically led to local troughs or declines in water consumption. You can see the Great Recession here with the unemployment rate literally doubling over about a 2-year period, and a corresponding decrease in consumption. Again, we looked at a lot of different indicators. We looked at housing permits, things that utilities can monitor and hopefully get a better sense of or a better way to anticipate what might be happening down the line. For example, we found that a decline in housing permits, or a shock to housing permits, showed up about, its maximum effect showed up about 29 months later than in terms of its maximum effect on consumption. So pretty interesting stuff. The best fitting model that we had for Tampa Bay Water was a combination of gross metro area product and the unemployment rate. And our point estimate suggests that those two factors contributed to about a 13.3% decline in consumption during the Great Recession. We also said, well, why don't we try to be a little more parsimonious and use a national leading index from the conference board to get a kind of a general sensing of the economy without specifying other independent variables. We see a very consistent estimate of about 13 to 14% decline. We were able to break that down into sectors, non-residential sector being the business sector, having the largest decline in consumption percentage-wise. So that was Tampa, big wholesaler on the East Coast. Now San Diego County, a large wholesaler on the West Coast that serves about 3 million people. They were able to give us not only regional water deliveries, but also population served. And so we were able to, in this case, look at per capita use from about 1975 through 2012. And consistent with this downward trend in consumption we're seeing, you can basically suggest that this gives a good indication of the long-term effects of water efficiency over time. And so what we wanted to do is say, all right, let's take that efficiency out and then correlate what's left with some of the economic indicators that we had at our disposal. And we had some leading indicators, and these are detrended. You can see the top component. This is an economic index from the conference board, and you can see the Great Recession and a great big drop in the leading index. But what also was going on during that time was some progressive increases in the real price of water to their members, the non-interruptible treated water rate. You can see a very large progressive increase in prices occurring at the same time. So if we break this down, we were able to produce point projections of the impact of kind of the economy at large on water deliveries in the San Diego region. And we saw that you could, in a counterfactual way, attribute about 14% swing downward in consumption to a downturn in the economy. Now, if you add the impacts of prices and to this equation, what you find is that we get about a 25% swing when you incorporate the increases in price along with the decline in macroeconomic activity. So this is a case where we have things happening procyclically to make variability more pronounced and more difficult to manage at the utility level. One last thing, or at least close to the last thing in terms of the economy, the elasticity or kind of the responsiveness to the economy or to water use to the economy differs by sector and geographic area. We had 4 case studies, and this shows the results of the responsiveness of our estimates for San Diego County and Tampa Bay Water for 3 different sectors. And you can see that the responsiveness or this elasticity differs by area. In both cases, there's a greater relative response, which we might expect in the non-residential or business sector than in the single-family or the multifamily residential sectors. Of note, though, in the San Diego example, the blue bar includes a lot of irrigation accounts. So how you classify does affect some of these results. But one thing to note that there is, single-family residential is the largest sector in both of these areas. So just keep in mind that it's just not a business impact. It's also a residential impact and largely tied to discretionary uses like lawn irrigation. Now, during this study, we found that not only did the economy really have just a short-run effect, there's reason to believe there's long-run effects of economic variables on water use. We found a lot of what we call co-integrating relationships with water use for several macroeconomic measures, meaning it's not spurious, that they are related over long time periods. For example, gross metro product, personal income, retail sales. I have a couple highlighted here, the labor force participation rate and price of water, because there's some interesting trends happening now in those factors. The blue line here plots the consumer price index for water and sewer from the Bureau of Labor Statistics, and the orange line is basically the consumer price index for all items. And so we see that the cost of water and sewer service is increasing, and that water and sewer prices are outpacing the general rate of inflation. So this is something to look at as we move into the future. With regard to the labor force participation rate, it basically is the percentage of the population working or actively seeking work. And it was interesting to see here that we're down to like 1978 levels in this indicator, which means to me that the water utility sector might have some long-term kind of socio-demographic challenges facing it as the workforce ages and we get more retirees. All right, so that's the economy. Now on to climate pretty quickly here. We did a study back in 2013, or we published back in 2013 a study looking at changes in water use under regional climate change scenarios. And if you know season, it's kind of like the kind of repeating seasonal patterns in climate alone, you can typically explain about 50% or more of the interannual variability in water use. So water-sensitive demands or climate-sensitive demands such as irrigation, cooling, pools, things like that really show up very well in the data. And then in the West, if you know basically climate patterns, you can explain as much as 90% of the interannual variability, at least in the places where I've worked. So here's using some USGS data that Howard mentioned. This is a plot of domestic public supply deliveries per capita day using the 2005 survey from USGS. Kind of a adequate estimate of what we might consider residential per capita use. And what you see here really is that there's climate-sensitive water use pretty much prevalent across the U.S., but obviously it's much more important as you get west of the Mississippi and then the southeast United States. So climate explains a lot of the variability we see in demand. Now, in our study, Project 4263, what we did is we took historical weather data, we downscaled climate information for certain case study areas, and basically plugged in these scenarios into water demand models that included climatic and weather variables, and compared our predictions under historical weather to predictions under some of our climate change scenarios. This table gives a summary of our case study utilities and estimated changes in annual use, not seasonal, but the entire year annual use, using a 2055 range of climate scenarios and a 2090 climate scenario. Each one of these 2055 and 2090 time slices have 5 different scenarios. The takeaway here is that all these are positive, meaning that in all these cases, the estimated impact of a new climate regime was increased demands. Another takeaway is that some of these are non-trivial changes upward in demand. For example, 23.2% increase in Colorado Springs, 45% increase in annual use in under 2090 climate. So demand's higher, and in some cases, some of the scenarios suggest quite large changes in demand. Now, this slide highlights our estimated summer water consumption using our, for our case studies using our demand weather models. I just wanted to throw in here what kind of changes in temperature and precipitation was, this hot, dry climate scenario in 2090, what was it giving us? And it looks like it's going to get really warm, in some of these places. If that scenario were to come true. In some cases, we will see lower rainfall, but not at all. But in all cases, we see quite a significant increase in demand relative to what we would expect under normal climate. And a note of interest here is that for Tampa Bay Water, if you were to receive half the rainfall that you get normally during the summer season, I think the 15% increase in demand is an understatement, because this is a real, would be a real new climate regime, which would really lay outside of the ability of our models to estimate. Just quickly here, there's a lot of ways in which climate change and climate variability can affect water use through what you might call the water demand function. So it's just not weather, but over longer periods where we live, what we produce, the technology we use, and the demand side, or the water customer, is going to be at the forefront of adaptation as well, in terms of what happens to pricing and conservation programs and potential curtailments that are implemented by water utilities. So when we're looking at water availability, I think it's crucial to not leave out considerations of our expectations of water demand. In closing, many factors influence the demand for water. I've gone through a few of these. Trends in technology, prices, and recent economic activity, at least, have contributed to the observed declines we've been seeing in many parts of the country. In terms of areas of uncertainty and reasonable expectations, I think technology will continue to improve water efficiency, which will put downward pressure on water use. Prices will continue to rise or catch up in some places that hadn't changed rates in a long time, which would also put downward pressure on demand. The economic cycles, like recessions and boom times, will continue. Really, hard, a bit of uncertainty about when those boom and bust cycles will occur. Climate change will affect seasonal consumption patterns in an unknown way, depending on the balance of water, of temperature and precipitation. And the last point here, urban areas will develop and redevelop to reflect prevailing preferences and tastes. And now this is a real large item with a great deal of uncertainty. Now, I did want to put a final plug in, if I have time, that, as a consumer myself of water utility data, as a consultant, I note that there's frequent needs for additional better and more consistent information for us to develop metrics and benchmark consumption and forecast and design rates. We did a study recently with the foundation to look at those issues and come up with some interim best practices in terms of standardizing data collection and the information that water utilities maintain about their customers that pertain to water demand studies. Now, if you think about the benefits of standardized data, I think there's a lot of potential benefits to enhance the quality of our national, basin, and regional water assessments if we're able to look at trends by sector, look at climate change impacts, economic impacts, and efficiency in a standardized and uniform way. One example is maybe being able to refine some of the public and domestic water withdrawal estimates or the categories that the USGS collects every 5 years or more frequently, maybe ways to improve EPA's portfolio manager, and of course the ability of planning and regulatory agencies to have better metrics to assess water use. But we know that water utilities are on the front line and they may benefit from an improved knowledge base, but they may not have an immediate need. So some of the external benefits of data standardization may exceed the internal benefits. And so with that in mind, as part of that study, we kind of laid out a proposal for what we might call the Water Demand Data Committee, with the idea to put some people together to ensure that the information benefits of uniform and standard data collection and analysis can be captured across perspectives. And what I mean by that is federal, state, regional agencies, utilities, researchers, and consultants like myself. With the idea of finalizing some requirements for standardization of customer classifications and the processes necessary to ensure they're uniform, establishing a desirable set of water use metrics and the information needed to calculate them. And lastly, to serve as a proponent, which I think is really important for articulating the benefits of water use data standardization, basically knowledge building, and to establish a common vernacular on the topics that really help us manage water better using better data. And so with that, this is my follow-up information. I want to acknowledge the Water Research Foundation and especially Maureen Hodgins. And so you can reach out to us if you want or can maybe get access to some of these reports I mentioned today. And then Maureen can give you a lot of details on a lot of the great work that they're doing. And with that, I'll end it there.